Good morning, students. In this video, we are going to discuss chapter elasticity for class 11. We start the chapter with the term deforming force. What is deforming force? A force which produces a change in the configuration of the object on applying it is called deforming force. In this diagram, we have a round shaped ball. On applying the force, the shape of ball is changed. So we can say the force is deforming force. So a force which produces a change in the configuration of the object on applying it is known as deforming force. So I think deforming force is clear to us. Deforming force is a force which is applicable when we want to change the shape of a body. In this diagram, the shape of the body is changed when a force is applied on it. What is elasticity? The elasticity is the property of the object by virtue of which it regains its original configuration after the removal of deforming force. If the body regains its original shape, we can say the body is elastic. And if the body is not able to regain its shape, then we can say it's a non-elastic. Question is next is, what is elastic limit? Elastic limit is the upper limit of deforming force up to which if deforming force is removed, the body regains its original form completely, and beyond which its deforming force is increased, the body has loses its property of elasticity and get permanently deformed. So we can say under the elastic limit, the body regains its elasticity property, and above the elastic limit, the body loses its property of elasticity. What is perfectly elastic bodies? Those bodies which regain its original configuration immediately and completely after the removal of deforming force, they are known as perfectly elastic bodies. For example, quartz and phosphorus, bronze, etc. They are the example of perfectly elastic bodies. The next topic is perfectly plastic bodies, the bodies which are not regain its original configuration at all. On the removal of deforming forces, they are known as perfectly plastic body. For example, paraffin and wax, etc. So if we discuss the perfectly elastic bodies, the body which regains its original configuration immediately and completely after the removal of deforming force are known as perfectly elastic bodies, and bodies which are not able to regain its original configuration, they are known as perfectly plastic bodies. Now we come, what is the stress? The internal restoring force acting per unit area is known as stress. The formula of stress is restoring force upon area. Its unit is Newton per meter square or Pascal, and the dimension is ml minus 1 t to the power minus 2. It is a tensor quality. The stress are classified into two types, normal stress and tangential stress. The normal stress is the deforming force applied normal to the area. It is known as normal stress. If the deforming force is applied tangential, then its stress is known as tangential stress. What is a strain? The fractional change in the configuration is known as a strain. So the formula of a strain becomes change in configuration upon original configuration. It has no unit and it's a dimensionless quality because it has ratio. There are three kinds of strain. Number one, longitudinal strain, change in length upon original length. Volumetric strain, change in volume upon original volume. Shearing strain, angular displacement of plane. What is the Hooke's law? Within the limit of elasticity, the stress is directly proportional to strain. That is known as Hooke's law. Under the elastic limits, the stress is proportional to strain. So the modulus of elasticity becomes stress upon strain. Types of modulus of elasticity. There are the three types of modulus of elasticity. Number one, Young modulus of elasticity. Number two, bulk modulus of elasticity. The third is modulus of rigidity. If I am talking about the Young modulus of elasticity, according to it, within the elastic limit up to which the Hooke law is applicable, the ratio of longitudinal stress to the longitudinal strain is known as Young modulus of elasticity. So the formula of Young modulus of elasticity can be given as longitudinal stress upon longitudinal strain. If we discuss about the bulk modulus of elasticity, we can say within the elastic limit up to which the Hooke's law is applicable, the ratio of the normal stress to the corresponding volume strain is known as bulk modulus of elasticity. If we talk about the modulus of rigidity, according to which within the elastic limit up to which Hooke's law is applicable, the ratio of shearing stress to the corresponding shearing strain is known as modulus of rigidity. So there are three kinds of modulus of elasticity. Young modulus of elasticity, the formula of Young modulus of elasticity is longitudinal stress upon longitudinal strain. Bulk model of elasticity, the formula of bulk model of elasticity is normal stress upon volume strain or pressure upon volume strain. Modulus of rigidity, the formula of modulus of rigidity is neta equals to shearing strain. So we can say there are three types of modulus of elasticity. And if we discuss about the elasticity, elasticity is the property of the material by virtue of which the body opposes any change in its shape or size when the deforming force are applied to it and recover its original body as soon as the deforming force is applicable. We also discuss about the Hooke's law. According to Hooke's law, under the elastic strain, stress is small, then the stress is proportional to strain. So in this video, we are discussing these things. Thank you.